Okay, hi and good evening. My name is Katiravan Manika. My metric number is 211022086. And my other members are Arvin Elgopan and Nulu Izashwini Binti Rosli. They will be presenting after this. So, the mini project for modern control system. Okay, entering into the first question, the question was find or create a transfer function with at least one k value, two poles, and three zeros. Seeing in the example below. Okay, so the given transfer function was this was the given transfer function. Okay, based on the given transfer function, we found out where the numerators are the zeros and the denominators are the poles. So we have our denominators over here and we have the poles over here. After doing some calculation, we will get the final value, and using this value, we will be inputting the value into scilab. Okay, and this is the value we will be using for inputting the scilab. Okay, so the second question was based on the above transfer function, use scilab and bode plot technique to illustrate this amplitude and response and phase response. Show the gain crossover frequency, phase crossover frequency, gain margin, and phase margin for the transfer function. Okay, this screenshot shows the line of codes that we inputted in Scilab in order to generate the graphs. Okay, and going to the graphs, we can see over here, this is the magnitude against frequency graph. Okay, we can see over here, this is the magnitude response graph. Based on the graph, we can see reaching at value 0, the graph breakouts over here and the value increases. And this is the phase response graph. We can see over here, the breakout also happens over here. If we zoom inside this graph, we can know that the breakout happens at 180 degrees. So that's all for my part. I will be giving the next part to Arvin. Oh, okay. Before ending my part, we also have this execution of code in order to get the gain margin. So the gain margin is 40.55 and the phase margin is 138.437 and the phase crossover frequency is 2.01 and the gain crossover frequency is 0.22. Okay, and then for question 3, I'll be passing to Arvin.
Hi, good evening. So today I'll be explaining about the question 3. So the question 3, what's the question 3? Let's look at it. So you must use both LED compensator to further improve 10% of the current phase margin of the response. Show the final transfer function of the compensator and its phase and its amplitude response. So you can use Scilab to draw the bot plot. So first, I have written down the current phase margin, which is 138.44 degrees, and the 10% of the 38.44 degrees is 13.844 degree. So to find the angle max, we have to use this formula, which is you have to plus the current phase margin and the 10% of the phase margin, and plus 15 degrees Celsius as a safety margin. So yeah, that's our zero max angle max value. After that, we have to find this equation GS equal to 1 over alpha TS over 1 over TS. So that is the equation. So to find the equation, we have to find the values of the alpha and the T value. So to find the alpha value, this is the formula I use. We are using zero max angle max equal to sine negative sine or over negative sine alpha minus 1 over alpha plus 1. So equal to 167 degrees, which is which where we get from above the this value max angle. So after substituting, we get the value of alpha as 1.58. So yeah. So after that, we can find the value of Wm. So to get the Wm value, we have to get the gain crossover frequency, which is 0.2264106, and we will have to convert it to radian per second. So the value is 1.4 radian per second. So yeah. So after substituting into this equation, we will get final value of the t which is 0.568. So after that, we have to substitute the values into the equations. So this is the equations, GS equation 1 plus 0.897 S over 1 pi over 1 plus 0.568 S. So I missed the S. So yeah. So after substituting it, this is the old, this is the new phase margin where I've used Scilab to generate it. So the required angle is 150 degree 52. So yeah, this is the new gain crossover frequency, which is 0.1769013. So yeah, this is the coding. to get the new phase margin and new gain crossover frequency. This is my GS equation, and this is my old transfer function, which where I derived from question 1. So yeah, this is the phase margin, new phase margin, and the new gain crossover frequency, and this is the ramp response of the new phase margin. This code I got from the lecture notes to get the ramp response. This is the ramp response. This is the Bode plot. So as you can see, the graph breaks at 0 for the amplitude response, and for the phase response, it breaks at 180. So yeah, it breaks at here. So for question 4, we have to use we have to use both a lag compensator to further improve 10% of the current phase margin of the response. So show the final transfer function of the compensator and its phase and its amplitude response. We can use scilab to draw the Bode plot. So same goes here, but here I have used angle max, which is 152.284 plus 5%, which is a safety margin for lag compensator. So same here, we have to find GS. GS is 1 plus the symbol is we call T, 1 plus TS over 1 plus alpha TS. So the frequency at this phase, which is negative 100 degrees plus 1572.84, it is we round off, we get negative 23 degrees Celsius. So the I think the WC is corner frequency. WC at 0. The WC at negative 23, which is we get from here, negative 23. We get this value 0.1 more 0.12 0.1216. So yeah, 0.1216 we get here. So this is the value I used, and I have converted to radian per second. And after that, we have to find the gain at WC. So the gain at WC is yeah, this magnitude we can get from here. Yeah, so yeah, 0.005797 dB. So the value we have to substitute in the value this is formula 20 log alpha. So we can get the alpha value 1.069. So yeah, this is the graph I showed just now to get the appropriate values. So here you can see I did a careless mistake. So later I'll correct it in a report 0.0 careless mistake. I have to use 0.1216. Yeah, and step 4, we have to put 0.1 decade below WC. So this is the formula I have used 1.1 the radian per second over 10 0.1413, and find the t value from where z equal to 1 over see, we have to substitute into this formula and find t, which is 7.0.77, and substitute all the values into the GS equation, which is 1 plus TS over 1 plus alpha TS. So I get the final value as this 1 plus 7.077 S over 1 plus 7.565 S. This is my new phase margin 135.214 degrees, and new gain crossover frequency 0.243678. So as you can see, this is my new phase margin and crossover frequency with, and this is the coding that I use, scilab coding to use. I used to get the phase margin and the gain crossover frequency, and this is the ramp response. This is the ramp response. This is the Bode plot. So you can see this is breaking at 0 here at this point, and we have this graph is breaking at 180. So the phase margin and the gain margin is showed above. So the next question will be explained by my teammate. So yeah, that's for my part. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum. My name is Nurul Isashri binti Rosli. So I will explain a little bit about question 5. So based on the question is based on your finding in question 3 and 4, which compensator that can be used to achieve 10% improvement of phase margin. So for lead compensator, original phase margin is 138.437, and then the required phase margin is 152. So after 10% improvement, the new phase margin is 159.63. For a lead compensator, the original phase margin is 138.437, 0.437, and then the required phase margin is 152, and then after 10% improvement, the new phase margin will be 135.21. So based on our finding, the capacitor that can be used to achieve 10% improvement of phase margin is the lead capacitor because it's certified the required phase margin. Thank you.